Now that we have reviewed exponent laws, we're going to take a look at the exponential function. And the exponential function is named as much because our graph or our function looks like y equals a to the power of x. So x is actually the exponent. The exponent is the variable. So notice that our base of a is what we are multiplying by x amount of times. Now, there are some limitations on the value of a. A has to be greater than 0. If we had a negative base, we would alter between negative, positive answers, which wouldn't give us a nice graph. And a cannot also be equal to 1. And it can't be equal to 1 because then our answer would always be the same. So a cannot be equal to 1. And other than that, a can be any real number. Some examples of exponential functions: anything where we have the variable as the exponent. So y equals 7 to the power of x, y equals 2.13 to the power of x, y equals 1/5 to the power of x. Those are all exponential functions because we're going to multiply the base x amount of times. So we want to take a look at what the graph of these functions is going to look like. So we have some examples here. Y equals 2 to the power of x. Well, that means that we're going to, again, multiply 2x times to find out what y has to be. Now, we're going to start over here at the 0. If we have y equals 2 to the power of 0, remember, anything to the power of 0 is just equal to 1. 2 to the power of 1 just means we have 2. 2 to the power of 2 is 2 times 2, which gives us 4. 2 to the power of 3 is 8. And 2 to the power of 4 is 16. Now, if we think about our negative exponents, remember we talked about last day that a negative exponent means we're going to flip our number. So y equals 2 to the power of -1 means that becomes a fraction and becomes 1 over 2 to the positive 1. So if we have y equals 2 to the -1, it's just equal to 1/2. Y equals 1 over 2 squared means we're going to get 1/4. Y equals 1 over 2 cubed means we're going to get 1 over 8. And y equals 1 over 2 to the 4 means we're going to get 1/16. For y equals 1/2 to the x, again, 1/2 to the power of 0 is just 1. Anything to the power of 0 is 1. 1/2 to the power of 1 is just 1/2. 1/2 squared is 1/4. 1/2 cubed is 1/8. And 1/2 to the power of 4 is 1 over 16. If we have y equals 1/2 to the -1, that means, again, that's going to flip and become 2 to the power of 1. So y equals 1/2 to the -1 is just 2. If we do 1/2 to the -2, becomes flipped 2 to the 2, which is 4. 2 to the 3 is 8. And 2 to the 3 is 16. For y equals 3 to the power of x, again, thinking about 3 to the 0 is 1. 3 to the power of 1 is 3. 3 squared is 9. 3 cubed is 27. And 3 to the power of 4 is 81. If we have to the negative, flips to 1/3 to the positive. So 1/3, 1/9, 1/27, and 1 over 81. Alternatively, we see that 1/3 to the 1 is 1/3. 1/3 cubed is 1/9. 1/3 squared is 1/9. 1/3 cubed is 1/27. And 1/3 to the power of 4 is 1/81. Flipped, y equals 1/3 to the -1 means it flips and becomes 3 to the 1, which is just 3. Squared is 9, 27, and 81. If we have y equals 4 to the power of x, following that same pattern, we have y to the, 4 to the power of 0 is just 1. 4, 16, 64, and 256. 1/4, 1/16, 1/64, and 1/256. Flipping it, still have 1/4 to the 0 is 1. We have 1/4, 1/16, 1/64, 1/256. Flipping it for the negative values means we have 4, 16, 64, and 256. Okay, so those are the numbers that we're going to use to graph. Now, I have already graphed these functions for saving a little bit of time. If you want to stop the video, make sure to use a full sheet of graph paper and take a look at mine for just a second. Note that we have no negative values for y, so you can use the positive y values for your whole sheet of graph paper. And notice that you're going to have to use some big numbers. We're not going to worry about our 256 or our big numbers like that. We should be able to fit 60, maybe even up to our 81 on our grid, depending how you scale it. But we do want to make sure that we can graph at least 2 or 3 points in the positive values for x. Okay, so if you want to stop the video and make your graphs, and then you can restart the video and take a look at our properties. So looking at that graph, we're going to take a look at, are the relations functions? Yes, they are. And the reason for that is because there are no repeating y values. And we can tell that from our graph because it passes our vertical line test. If we take a vertical line all across those x values, our graph never passes that vertical line more than once. Now, if we look at our domain, we see that there are no restrictions to our x value. We can sub any value in there. We can even sub decimals in there if we want. We can still calculate a y value. Now, our range though, notice that I mentioned that we don't have any negative y values. We actually cannot even get to 0. If you look at your fractions in our table, so above here, the bigger our x value gets, the smaller the number gets, but it's just going to be a bigger and bigger number on the bottom of our fraction. It's never actually going to be equal to 0. We can never get to 0. So our y values are y such that y has to be greater than 0. Notice not greater than or equal to, just greater than 0. And as long as they are, it's any number. We do have a continuous line. Now, our equation of the asymptote. An asymptote is a line that our graph approaches but never gets to. So an asymptote is a line which the graph approaches or gets closer and closer, but never touches or crosses. So the equation of our asymptote for these graphs, if we take a look at this, we have a straight line here in which all of our graphs get closer and closer to this horizontal line, but they never cross. And our equation for that line is y equals 0. So our asymptote, the equation is y equals 0. Our y-intercept, if we take a look at, we notice that all of our graphs cross at 1 on the y-axis. And our x-intercept, because our asymptote is at y equals 0, that means it's never going to cross our x-axis, and there are no x-intercepts for that relationship. Now, a couple of observations about our graphs. Notice that, first of all, y equals a to the power of x and y equals 1 over a to the power of x are reflections of each other in the y-axis, meaning that we could put a mirror right on that y-axis and see that it's exactly the same, they're just flipped around the y-axis. So that means that y equals 2 to the power of x and y equals 1/2 to the power of x are reflections. So we notice that these two graphs are flipped around this y-axis. A second thing that we want to notice is that if our base is greater than 1, so if we have 2, 3, 4, we have an increasing function. And if we have a less than 1, or between 0 and 1, so if a is greater than 0 but less than 1, we have decreasing functions. And we also want to make note of, as our base gets bigger, our graphs get taller. They increase for our numbers greater than 1 at a quicker rate. So when we look at our y equals 4x, it is much taller than our y equals 3x, which is much taller than our y equals 2x. So as that base value gets bigger, we're multiplying that bigger number by itself x amount of times, it is going to increase or decrease in these graphs at a quicker rate. Okay, so that's our introduction to exponential functions. You can take a look at your worksheet for